Okay, and here we go in the very end of 2.4, solving word problems involving right triangles. Now, if you're watching this video, then you were not there when we went over these because we did these in class, and then I put the video online. So you're either going, oh, I need to look at this again, or you weren't there on the day that we went over it in class. So you're going to solve word problems using the trig function, sine, cosine, and tangent, and right triangles. So a couple of concept questions first. The first one is, can an angle of elevation be more than 90 degrees? Yes or no. They're not asking you for any explanation, just yes or no. And the answer is no. Because keep in mind, angle of elevation is from your line of sight, a horizontal line of sight, up. And greater than 90 degrees would mean that you're basically got your head detached from your body and looking over your head. So this would be well over here is greater than 90, so no, that can't happen. Okay, next question, explain why the angle of depression DAB, this angle here, has the same measure of the angle of elevation ABC, which is this angle here. The question is, why are these the same measure? Well, first of all, they do tell us that AD and erase that, AD and BC are parallel. So let's go ahead and mark those with the parallel symbols. Those are parallel symbols. And then we get to go back to geometry, and if we have parallel lines cut by a transversal, then your alternate interior angles are congruent. So this would be an alternate interior angle from the transversal line of the parallel line, and from here from the transversal to a parallel line, this angle here, so they are congruent. And this is one of the last problems in the last section. I was showing you guys that you can do, instead of finishing off your triangle up here, just bring it down here. Okay, the third concept question, why is angle CAB not an angle of depression in the figure for exercise 39? And that would be just the definition of angle of depression. It is a line of sight to a horizontal line. And this line here is a vertical line. So, and that's why this would be your angle of depression. Right here would be an angle of depression. Okay, so let's look at some word problems here. It says the height of a ladder on a wall. A 13.5 meter fire truck ladder is leaning against a wall. There it is, 13.5, there's the ladder. Find the distance D the ladder goes up the wall above the top of the fire truck. So they're going from the top of the fire truck, how far up the building does it go? If the ladder makes an angle of 43 degrees 50 minutes with the horizontal. So we have an angle of elevation here. Angle of elevation, we're looking for this, we're looking for this. This is equivalent to the hypotenuse, important to know, and this would be the side opposite. So we're going to use sine. So sine of 43 degrees 50 minutes equals opposite, which is D, over the hypotenuse, which is 13.5. By the way, significant digits here would be 3. Multiply both sides by 13.5 and we get 13.5 sine of 43 degrees 50 minutes equals D. And at this point, all we have to do is throw that thing into the calculator, and we get G equals 9.35 meters. 3 significant digits. Even though this only has one decimal place, we are looking for 3 significant digits. and there's your answer. So from the fire truck on up is 9.35 meters. We don't know this part. Word problem deserves word answers. So find the distance D. The ladder goes up the wall. The ladder from the top of the fire truck the ladder from the top of the fire truck goes up the wall (9.35 meters). Okay. On a test, yes, I will be watching for things like this. Okay, next question, 43, height of a building. Now this is a more difficult type problem. It says from a window 30 feet above the street, the angle of elevation to the top of the building across the street is 50. So they're giving you this angle of elevation here of 50. And the angle of depression to the base of this building is 20 degrees. So they're giving you that angle of depression. Find the height of the building across the street. So they want this whole thing. So you've got two things to solve here. So since we have this side, we have this bit, all we have to do is calculate what the distance across the street is so that we can find this bit. So we're looking at this value. This is the first value we're looking for. So no hypotenuse. This is my hypotenuse. From 20, this is my opposite side. And this is my adjacent side. So opposite and adjacent, we're using tangent. So tangent of 30, I lied, tangent of 20 is equal to opposite, which is 30, over x. Cross multiply, we get x tangent of 20 equals 30, divide by tangent, and x equals 30 over tangent of 20, which gives us a value of I didn't write this down. Hold on a second. Let's throw this in the calculator and figure this one out. 30 divided by tangent of 20 equals 82.4243. Okay, 82.4243. More. Now, ladies and gentlemen, we have to use all of those digits because that's not the answer we're looking for. That's just how far apart these two buildings are. So when I am looking for that answer in the end, I cannot just go, oh, three significant digits, 82.4. And for those of you, you can even go, oh, no, really, we're looking for two significant digits. I lost my cursor. Okay, so let's try this one again since it paused on me. So anyways, this particular problem, that 82 is not the answer that we're looking for. It's just going to get us to the answer. But we now know that this guy here, oops, let me get my pen back. This guy here is that length across the street. Now we need to get this answer. So this time it's still tangent, but we're going to use the 50-degree angle. So we're going to tangent of 50 equals the opposite. So now, again, this is still opposite. So y over this amount, which is this amount. And I need to make sure that you go, okay, that amount. I'm going to put the 82 point something, but what I'll have to do is I have to grab this off the calculator. So if I move this over, this becomes 82 point something times tangent of 50 equals y. So now this is still in my calculator, so I'm going to take that 82 point something and then multiply it by tangent of 50. And that gives me y equals 98.229. Now, I'm going to go back to that significant digit idea that all of these are using 3. They got the 0.0, 0.0, 0.0, so we're going to use 1 decimal place on ours as well. So this is going to give us a 98.2 plus the 30, because I need to make sure you're aware that that 98.2 is this bit up here. I don't know where these lines are coming from. So 98.2 plus 30 gives us a value of 128.2, and I believe this is in feet. Feet. And then we write it out. The height of the building across the street is 128.2 feet. Okay, next question. Okay, side lengths of a triangle. The length of the base of an isosceles triangle is 42.36 inches. Each base angle is 38.12 degrees. Find the length of each of the 2 equal sides of the triangle. And it says, hint, divide the triangle into 2 right triangles. Okay, so we're going to grab this thing here, and we're going to divide our triangle. Okay, now this is where you get to get that little reminder from geometry. And in an isosceles right triangle, these 2 sides are congruent. And when you put this guy through here, he becomes an actual perpendicular bisector, which means it not only bisects this angle up here, but it bisects the line down here and forms right angles. So now we have right angles. This is 42.36, so half of 42.36 is going to give us 21.18. So this is 21.18 and this is 21.18, and giving us the full length of 42.36. All I did was divide it in half. 42.36 divided by 2. Now, these base angles, they're telling us both of these base angles are 38.12 degrees. Okay, and what I need to do is know this side here. So from this would be my opposite side. This is my right angle. This would be the hypotenuse. And this would be adjacent. And this is what I want, is the hypotenuse. So we're going to label him X. I don't care about this side. I'm just identifying my opposite, adjacent, and hypotenuse. So since I have adjacent and I want the hypotenuse, we are using cosine. So cosine of 38.12 degrees equals adjacent, which is 21.18. 26.18 over my hypotenuse. So cross multiply, we get the hypotenuse, I know I was going to say it was x, but just make it easier, times the cosine of 38.12 degrees equals 21.18. What is the measurement on that one? Inches. All right. And then divide by cosine, we get hypotenuse equals 21.18 over the cosine of 38.12. So the hypotenuse equals, throw this in our handy dandy calculator, 26.92.9219. Okay, now significant digits. It looks like our significant digits equals 4. So the length of our two equal sides, there it is, the length of the two equal sides is 26.92 inches. There you go on that one. You guys went, okay, cool, not a bad deal here. There you guys go. Okay, next one. Angle of elevation of the Pyramid of the Sun. The Pyramid of the Sun in the ancient Mexican city of, I'm not going to try to pronounce it, was the largest and most important structure in the city. The base is a square with 700 feet long, and the height of the pyramid is 200 feet. And we've got a nice little picture here, 3D picture, so you can see it. Find the angle of elevation of the edge indicated in the figure to two significant digits. Okay, they're telling us. Hence, the base of the triangle in the figure is half the diagonal of the square base of the pyramid. So, we'll go through that. Now, let me explain the picture here. This is the picture in the book. This is not the Pyramid of the Sun. Why, Miss Harder, how do you know that is not the Pyramid of the Sun? Because I've been there. And this, tourist in the middle of my picture here, this is the Pyramid of the Sun. So I just replaced the picture with one of my own. Okay, so back to the problem. We need this length. We already have this length. And actually they're wanting this length, but we need, because we don't know the angle of elevation, we need this length. And they said it's half the diagonal. Well, the diagonal, I'm going to let you know right now, is going to be 700 square root of 2 is the diagonal. Why, Miss Harder, you're so quick and so fast. How did you figure that one out? Pythagorean. A squared plus b squared equals c squared. And the triangle I'm looking at is this side, and then the diagonal. And so you get 700 squared plus 700 squared, which will give you 49, 4 plus 49,000. And you put these two together, there's two of them there, so you get 2 times that 49,000 equals c squared, and you take the square root of both of these, and you get the square root of 2 times 700 equals c. But now remember, it did tell you up here that it is the base of the triangle in the figure is half the diagonal. So I need to take half of this. So this c, I'm going to move this guy over so he's out of our way. This 700 square root of 2 is the whole length there. And so the length of just this is going to be half. So c equals 3 equals that amount. So So this is 350 square root of 2. And now this is the triangle we're looking at. And they are asking us for this length here. Are they asking for the length, or are they asking for the find the angle of elevation? Oh, we're not looking for, we don't care about that length. We're looking for the angle of elevation to that side. Got it. I'm going, this is not trig. All right. So now we have the adjacent side and we have the opposite side. So we get to use tangent. Tangent of theta equals opposite, which is 200, over 350 square root of 2. This is the arctangent, so I can do that arctangent here, arctangent here. So you get theta equals the arctangent of 200 over 350 square root of 2. And then you're going to throw that into the calculator, and we'll get 2 radical 2 over 7. If you cleaned it up, we're not going to clean it up. We're going to throw this straight into the calculator, and you will get, actually let me go ahead and throw it in, because 200 divided by 350 radical 2. And I put in tangent instead of arctangent, which gives us 22.00, but they wanted it to 2 significant digits. So the angle of elevation is is 22 degrees. There's your angle of elevation on that one. Let's see, it looks like we've got 2 more to go here. Next one, height of a tower. The shadow of a vertical tower is 20.6 meters long when the angle of elevation of the sun is 34.6. Find the height of the tower. So I'm going to grab some lines here, that way my lines will look a little bit better. So I'm going to throw a tower here. You're going, okay, cool, tower. Throw a shadow in here. There's my shadow. I'm going to even throw a sun in there. Let's see, we want a little fancy pan here. There's my sun. Okay, too many of them. Just like we would have done that when we were kids, a little sun with smiley face and the rays coming out. Okay, so back to the question was asking again. The shadow of a vertical tower is 40.6 meters long. 40.6 meters. When the angle of elevation of the sun is 34.6. So I need my lines again. No, not that one. That one. That way I have my triangle that's really not there. And my angle of elevation is 34.6 degrees. They want to know what is the height of the tower. So we're looking for this. Okay, so from my angle, this would be opposite. This would be adjacent. And there's my hypotenuse. Don't worry about my hypotenuse. I'm looking for my opposite side, and I have the adjacent, so we're going to use tangent. So tangent of 34.6 degrees equals x over 40.6. multiply both sides by 40.6, and we get 40.6 tangent of 34.6 equals x. So we throw this into the calculator. And we get 28.00 meters. So there's our x value, x equals, and we're looking at really 3 significant digits. So the height of the tower is 28.0 meters. Okay, one more. I know the video's giving up, but we're good. Okay, length of a shadow. Suppose if the angle of elevation of the sun is 23.4 degrees. There it is. Find the length of the shadow cast by Diane Carr, who is 5.75. So here's the sun, it's hitting her, and it's forming this shadow. So really, that's the area we're looking for, just back here. So this would be my hypotenuse. This is my opposite side. This is my adjacent side. And again, we are looking for the adjacent. We have the opposite. We don't need a hypotenuse, so we're using a tangent again. So tangent of 23.4 degrees equals opposite, which is 5.75 feet, over x. Cross multiply, we get x tangent of 23.4 equals 5.75 feet. Divide by tangent. So we get x equals 5.75 divided by the tangent of 23.4. And we throw this into the calculator, and we get 5.75 divided by the tangent of 23.4, 13.287. Okay, and significant digits on this guy is 3, so we want 3 on this. So 13.3. So the length of Diane's shadow is 13.3 feet. Okay, and that is that on this one here. Again, this was homework. Every one of these were homework problems. So this gave you the opportunity to look at something if you were struggling with something. But again, if you're watching this video, you either did it because we already went through it in class and you wanted to watch it again, or you were not there the day we went through it. So good luck.